Hello, this is Dr. Oz. Today, I would like to show you another application of linear programming. This time, I will give you a marketing example. We can use linear programs in, let's say, advertising campaigns and to allocate our fixed budget, advertising budget, using different advertising options. The objective in these kind of marketing decisions is to either maximize the reach, frequency, quality of exposure, and so on. Not necessarily dollar, but some other qualitative measures that matters for our company. Some restrictions or constraints in this kind of models. Company policies may have some requirements. We may have some contracts with our clients or suppliers, and the availability of the media. All right, so let's talk about a small case study here. Relax and Enjoy Lake Development Corporation has a trying to develop a lakeside community at a private lake, and their primary market is middle and upper income families within 100 miles of the development. And they hired Bond, Phillips, and Jackson, BP&J, to design their promotional campaign. And BP&J came up with, after extensive research, following 5 options. 1, having a daytime TV advertising campaign using channel WKLA for minute. Option 2, evening TV campaign for 30 seconds each at, again, WKLA. Third option is daily newspaper, 1 full page at the Morning Journal. Option number 4, Sunday newspaper magazine, half a page at the Sunday Press. Finally, radio campaign between 8 a.m. Or 5 p.m. news for 30 seconds at station KNOP. So each of these options for our firm have different requirements and costs and so on, outcomes associated with them. So if I use, let's say, daytime TV, which is the first option, I can reach to around 1,000 people. And again, I need to do extensive research to understand the potential customers' reach. However, if I go with Sunday newspaper magazine, I could have 2,500, which is better. Cost, cheapest option here looks like the radio. It's only $100 per advertisement. But the most expensive one here is evening TV for 30 seconds is $3,000. And I cannot just buy infinite number of these advertising options. There are some limits. Looks like the hardest thing to get into is Sunday newspaper. Only 4 available for me this month. If I want to go with radio, pretty much I can have it every single day. So the exposure quality, again, this can be measured in different ways based on how people see it, whether they listen or not, whether they follow up or not, whether that will create a loyalty or brand recognition for my company. So it looks like the best quality is with 90 exposure quality units is evening time. The first one is radio. It has very minimal effect. However, as you please remember, it's very cheap. So in this problem, I have only $30,000 given to me to spend. And I have some restrictions. My company executives of the owner wants to have TV presence, at least 10 commercials. And we would like to have at least reaching to 50,000 customers so that we can sell some of those beautiful units. And I cannot spend more than $18,000 on my TV because I would like to use other options as well. Because based on my research, TV is good, but not everyone is watching TV. So here in this problem, it's important to define what is our decision. In this case, the decision variables or decision that I'm trying to make is how many times to use each medium. So that's what I'm trying to decide. I have 5 mediums and I'm trying to decide how many times each should be used. And these are my decision variables, right? Medium number 1, daytime TV, evening time TV, ETV. DN is daily newspaper use, SN is Sunday newspaper use, and R is radio. And the objective in this model is maximize the total exposure. Higher the exposure I have, higher chance of selling my units. So let's write the constraint here. Before constraints, we define the decision variable. Let's write the objective function here, okay? So here is the objective function. I'm trying to maximize my exposure quality. So every daytime TV ad will give me 65 points. So 65 DTV plus every evening TV commercial will give me 90 points plus every daytime daily newspaper campaign or advertising will give me 40 points. Every Sunday newspaper advertising will give me 60 points. And finally, every radio advertising will give me 20 points. So I'm trying to maximize this. And I have constraints for availability. In this case, availability constraints. DTV is only available to me up to 15 times, so less than or equal to constraint. ETV is available up to 10 times this month. DN is available to me up to 25 times. SN is available to me up to 4 times this month. R, which is radio, is available to me up to 30 times this month. And I have my budget constraint as well. Subject to. Budget constraint here is the right-hand side value is I have $30,000 to spend. So every daytime TV ad will cost me $1,500 times DTV plus every ETV, evening TV ad, will cost me $3,000 plus every daily news will cost me $400 plus every Sunday news will cost me $1,000 plus every radio ad will cost me $100. All right, so I have some more constraints. Let's use the next slide to write them down. I have TV constraint, which is defined by my executives. Daytime TV plus evening time TV should be greater than or equal to 10 times in this month. Other restriction, budget restriction that I have is that amount of money that I spend for DTV and ETV should be less than or equal to $18,000. Also, I would like to have customer reach, minimum customer reach constraint. So I know that 1,000 reach per DTV plus 2,000 reach for ETV plus 1,500 reach for DN plus 2,500 reach for SN plus 300 radio should be greater than or equal to 50,000 reach. Finally, I have non-negativity constraints such that DTV and ETV and DN and SN and R should be greater than or equal to 0, right? So this is our model. As you see, I have maximization problem, trying to maximize my reach. I have availability constraints here. I have 5 of them for each medium. I have 5 constraints here. I have a budget constraint here, 6. I have TV constraint here, 7. I have restriction constraint, 8. I have customer reach constraint, 9, and I have 5 non-negativity constraints. So I have 14 constraints and 5 decision variables. And I will solve this problem using Excel Solver in our next video. Until then, enjoy business analytics.